Hey everyone, get ready to measure up. Because today's deep dive might just change the way you see the world, literally. We're diving into something you use practically every day: measurement.
Now, before you tune out thinking this is a boring trip back to middle school math class, I promise you, there's so much more to it than meets the eye.
Right.
Imagine this. You're 11 years old, you're getting ready for school, and your mom drags you to the tailor for a new uniform, your old one. Yeah, let's just say growth spurts are a thing, but here's where it gets interesting. Instead of centimeters or inches, you hear your mom telling the tailor to make it charangula longer. That's 4 finger widths.
Yeah.
Now, why are we talking about finger widths in the 21st century?
Well, it highlights just how deeply woven measurement is into the history of civilizations, and sometimes even their present.
What's fascinating is that this isn't just a charming anecdote about old-school tailoring. Ancient India, for instance, had amazingly advanced measurement systems. They used units like the angula, that finger width we just talked about, the dhanusa, which was based on the length of a bow, and even the yochana to figure out distances between cities.
Okay, hold up. So you're telling me that even today, in a world of lasers and digital precision, some people still rely on these ancient systems?
You bet. Think about carpenters who need to make quick estimations or tailors doing intricate works, those traditional methods. They're still incredibly practical and precise, and it goes way beyond India. The Harappan civilization, known for their incredible urban planning, likely used standardized tools for measurement thousands of years ago.
Pretty mind-blowing, right?
That is absolutely wild. Okay, so we've gone from finger width to standardized tools used by ancient civilizations. But let's bring it back to those finger widths for a second.
Yeah.
Let's say everyone in your class was asked to measure the length of a table using only their hand spans. Do you think everyone would get the same answer?
That's a recipe for chaos, isn't it? You'd have tables of all different sizes and nothing would quite fit together. That, my friend, is exactly why standardized units became absolutely essential, especially for things like trade, construction, and science.
So enter the International System of Units, better known as the SI system.
Exactly. The SI system, with the meter as its superstar for measuring length, wasn't just about creating rules for the sake of it. It was about solving that problem of consistency, about making sure that whether you're in India, Greece, or even on Mars someday, a meter means the same thing. It's about a common language for understanding the world around us.
That's such a cool way to think about it. It's like the metric system is the ultimate translator for measurements.
You got it. It helps us break down those walls and collaborate on a global scale. And that collaboration, that's what helps us make those groundbreaking discoveries and innovations.
Speaking of understanding the world around us, it's not just about knowing how doubly long something is, but also how that something moves.
Have you ever been sitting on a train and the train next to you starts moving, but for a second you can't tell if it's your train or theirs that's actually in motion?
That, my friend, is the concept of relative motion in action. It completely messes with your perception. It all comes down to your frame of reference. What are you using as a fixed point to compare the motion to?
That's such a mind-bending concept. It's like, what even is motion if it all depends on your perspective?
Well, think about it this way. Even when you feel like you're standing perfectly still, you're actually hurtling through space on this giant spaceship we call Earth. Pretty wild, right?
But to make sense of all this motion, it helps to break it down into different types.
Okay, so it's not just as simple as moving and not moving. Tell me more.
You got it. Let's start with something we all know: walking. When you're walking in a straight line, that's linear motion. Then there's circular motion, like the wheels on a bike or the spin cycle on your washing machine. And how could we forget oscillatory motion? Think of a pendulum swinging back and forth, or even that slight vibration you feel when your phone is on silent.
Okay, so linear, circular, and oscillatory. It's like a physics dance party in here. But seriously, why does understanding these different types of motion even matter in our everyday lives?
Because it helps us describe and explain so much of the world around us. From the way your car engine works to the graceful arc of a basketball being thrown through a hoop. It's all about recognizing patterns and understanding the forces at play.
So it's not just about planets orbiting the sun and all that big picture stuff. It really is all around us.
Absolutely. Think about it. When you hit the brakes on your car, you're changing its linear motion. When you turn a corner, you're incorporating circular motion. And that bumpy road that's making your car shake.
Hello, oscillatory motion. You're practically a physics pro behind the wheel.
Wow, I never thought about it like that. It's like physics is hiding in plain sight, just waiting for us to notice it.
And once you start noticing, you'll see it everywhere. It's all about paying attention to the world around us. and asking those why questions. Why do things move the way they do? What forces are at play? That's how we begin to unravel the mysteries of the universe.
Okay, so from ancient measuring techniques to the physics of a bumpy car ride, we've covered a lot of ground.
Before we let you go, what's the one big takeaway you want our listeners to walk away with today?
You know, it's fascinating how even something as seeming...
Absolutely.
Yeah.
We might not always have all the answers, but even the simplest act of observation can lead to some pretty incredible discoveries. So the next time you see a measurement, don't just see a number.
Or when you see something in motion, don't just see it going from point A to point B.
Right. Think about the history behind those measurements, the purpose they serve, and how our understanding of motion shapes the way we see the world.
Beautifully said. Well, folks, that's all the time we have for today's deep dive. But remember, this is just the beginning. Keep those brains buzzing, keep asking those why questions, and, most importantly, keep exploring the fascinating world around you. Until next time.